All right, let's get right into it. Welcome to this exclusive, high-level executive briefing. Today, we're diving into an explainer of the Sovereign 2 L6 Ellerite 6 prototype. Now, as we go through this, I really want you to envision the data and the schematics we're exploring, not just as flat blueprints on a screen, but as a dynamic HD 10K 3D rendering. Picture these components actively moving, rotating, and firing right in front of you. We aren't just looking at basic engineering today, we're analyzing an absolute masterclass in industrial design that completely redefines electromotive propulsion. This is all about seeing exactly how cutting-edge mechanical architecture directly translates into massive, strategic business value.
Okay, let's look at our roadmap. We're going to start with the macro view of the Sovereign 2 prototype, dissect the core architecture and materials, zoom right into the last MOSFET advantage, review those critical performance metrics, and finally, synthesize all of this into pure strategic business value.
Section 1. The Sovereign 2 prototype. This is, without a doubt, a completely new paradigm in electromagnetic reciprocating motors.
Imagine this Sovereign 2 L6 ALAR 6 prototype rotating right now on a vibrant video display. Just look at the sheer scale and the pure intent of this design. Down at the bottom, notice the heavy inertial counterbalanced camshafts driving that mechanical rhythm. And up top, see the inset detailing the horizontal firing profile? It fires in a perfectly orchestrated 1-5-3-6-2-4 sequence. You know, this isn't some random combustion sequence, it's a highly calibrated electromagnetic rhythm built specifically for continuous, ultra-smooth industrial power delivery. It's breathtaking engineering, but the real magic is the sum of these incredible parts.
Moving on to Section 2, Core Architecture and Materials. These are engineered for unmatched durability and, ultimately, your ROI.
When you look at these specifications, you really shouldn't just see a materials list. You need to see massive reductions in maintenance overhead. The housing itself is a 316L stainless steel stressed member skeleton monoblock. What that means is the chassis handles extreme torsional stress without microfracturing over time. Add to that titanium connecting rods, giving you the ultimate strength-to-weight ratio. Inside, we have N55 neodymium magnetic pistons acting as movable cores, interacting with sleeved transformer coils that use this highly distinct, egg-shaped tapered flux focusing geometry. Actually, scratch the idea of them just being premium materials. They are purely strategic capital investments engineered for decades of rock-solid operational stability.
To really understand how those N55 neodymium pistons achieve such incredible force, we have to talk about their Hallback array configuration. By arranging the permanent magnets to augment the magnetic field on the working side while practically canceling it on the non-working side, the Sovereign 2 achieves pure axial flux optimization. So, what does that mean for your bottom line? It means one very important thing: vastly superior power density without needing a larger, heavier footprint. It's incredibly efficient.
Which brings us to Section 3, the LAS MOSFET advantage. This is all about securing the micro-level proprietary edge. Check this out. This is the LAS Rejoiner Standard Component MOSFET. In an electromotive propulsion core of this magnitude, standard off-the-shelf logic controls would literally fry under the electromagnetic load in seconds. Notice the base of this component. It features dual custom heat sinks. This specific design guarantees thermal dissipation even under the most extreme, continuous industrial stress, keeping the logic pathways totally stable while running the Sovereign 2's independent gate driver boards.
Now, what's really interesting here is that custom fourth pin protruding alongside the standard drain, gate, and source. This was explicitly designed by Jacob Ray Last to handle what's known as the Jacob 1 timed path. Now, why does this matter to us in the C-suite? Because this isn't just a hardware component. It is an absolute, impenetrable intellectual property moat. It enables completely exclusive proprietary logic control over the gate timing. It makes the core technology exceptionally difficult, if not impossible, for competitors to reverse engineer.
Let's look at the hard data validating that proprietary logic. When we check out the specifications for the LAS MOSFET, the numbers are just staggering. We're looking at high voltage handling up to 2500 volts. The standard timing precision sits at 10.0 milliseconds, but the ultimate timing precision, it clocks in at an astounding, basically unheard of 0.00 milliseconds. For any industrial system, these metrics represent extreme reliability and a perfectly flawless operational cadence.
Let's move to Section 4, Performance and Stability Metrics. This is where we validate that operational superiority.
2,500 volts. Just let that number sink in for a second. To put that into perspective, your standard high-power industrial line runs at just a fraction of that.
Because the LASA MOSFET can effortlessly handle 2500 volts, the Sovereign 2's independent gate driver boards have massive operational headroom. They can manage violent spikes in electrical loads without failing. That means your industrial applications can push harder for much longer with zero risk of a catastrophic electrical blowout.
But the true marvel here is that 0.00 millisecond ultimate timing precision. In the Sovereign 2, this electronic precision is married directly to mechanical cam-actuated optical timing triggers, which you might have spotted earlier on the straight mechanical setup of the blueprint. The result? Perfect, absolute synchronization. There is zero hesitation between the mechanical crank position input and the MOSFET gate timing. That ensures maximum energy transfer on every single stroke.
Directing your attention back to our high-definition blueprint, let's zoom in on the bottom right corner. Here we have the ultimate validation graphs, the system harmonic resonance verification on the left, and the Lorentz force versus stroke position on the right. Guys, these aren't just theoretical curves drawn up in a lab. They are the empirical, hard proof of the Sovereign 2's superiority.
Look closely at that system harmonic resonance graph. The single most impressive metric is right there, zero primary imbalance. In heavy machinery, primary imbalance causes those violent structural vibrations that literally tear amounts apart and waste massive amounts of kinetic energy. But the Sovereign 2 achieves zero primary imbalance. This translates to incredibly smooth operation, massively extended lifespans for all your surrounding infrastructure, and absolutely zero wasted kinetic energy.
And this brilliantly illustrates the real-world output, predictable power. That beautifully smooth Lorentz force versus stroke position curve guarantees that the power delivery isn't erratic or spiky. It is perfectly smooth and infinitely scalable. For your day-to-day operations, this means absolute predictability. You can rely on consistent, highly controllable performance, whether the system is just idling or running at maximum industrial capacity.
Finally, we reach Section 5, Strategic Business Value, the executive bottom line.
Let's just contrast the status quo with the Sovereign 2 for a minute. Standard industry motors constantly bleed energy through heat loss, they suffer from high wear and tear, and they rely on super vulnerable standard logic controls. The Sovereign 2 architecture, on the other hand, employs resonant switching back EMF recovery dumpster capacitors. That literally means capturing and reusing the exact energy that standard motors just throw away as waste. It cools itself internally using pneumatic dampening air sleeve vents linked right to a forced air cooling manifold. And of course, it operates exclusively on that secure, proprietary Jacob 1 logic. The efficiency gap here is just staggering.
So here is your logical progression, your actual roadmap to market dominance. Step 1. The premium 316L and titanium construction effectively eliminates early mechanical failure, drastically slashing your CapEx replacement cycles. Step 2. The proprietary LASS MOSFETs with that custom fourth pin create an incredibly defensible market advantage, fully protecting your operational IP. And Step 3. The zero primary imbalance ensures that every single ounce of energy put into the system generates useful work. That directly maximizes your energy efficiency and absolutely skyrockets your ROI.
We've seen the data. We've explored the schematics. With its zero primary imbalance, its 0.00 millisecond timing precision, and that unhackable proprietary logic control, the real question isn't whether the Sovereign 2 is going to disrupt electromotive propulsion. The real question is your infrastructure ready to harness it before your competitors do? Think about that as you consider your next high-level strategic investments. Thank you so much for joining me for this Executive Explainer.